Hello students. So today I am doing class for class 12. The topic is the same topic, that is first order derivative. This is also the continuation class. Same exercise 3A. Each question carries 5 marks. That is from page number 294. Right? So now question number 16. If 1 plus x whole to the power n is equal to c0 plus c1x plus c2x square plus c3x cube plus plus cnx to the power n. So you know that this formula is known as the binomial expansion. So this binomial expansion or binomial theorem is done in class 11. I think you did it, right? And now in this case, this c0, c1, c2, c3 cn are known as binomial coefficient, or this is also known as constant. Only the variable here is x. Okay, so this is the given part. 1 plus x whole to the power n is equal to c0 plus c1x plus c2x square plus c3x cube plus plus cnx to the power n. So using differentiation, you have to prove these two relations. So number one relation is c0 plus 2c1 plus 3c2 plus plus n plus 1 cn is equal to n plus 2 into 2 to the power n minus 1. You have to prove this relation first, and then you have to prove the second relation, that is c1 minus 2c2 plus 3c3 minus plus minus 1 whole to the power n minus 1 into n dot cn, which is equal to 0. Okay, so let us prove it. Let us prove number one from the given binomial expansions. Okay, so number one. So what is the given expansion out here? It is 1 plus x whole to the power n is equal to c0 plus c1x plus c2x square plus c3x cube plus plus it is cnx to the power n. Okay, so this is the binomial expansion or binomial theorem, and where this c0, c1, c2, c3 cn are known as binomial coefficient, or it is also known as, they are also known as constant also. So using differentiation, you have to prove relation number one. Okay, now differentiate both the sides with respect to x. So differentiating both the sides with respect to x, right? So therefore, what is the differentiation of 1 plus x whole to the power n? It is just like your x to the power n. What is the differentiation of x to the power n? N into 1 plus x whole to the power n minus 1 into, again according to the rule, you have to find out the differentiation of 1 plus x with respect to x. That is always 1. 0 plus 1 is 1 always, isn't it? So is equal to, so what is the differentiation of only 0? Constant is 0. But c1 is with x. What is the differentiation of x with respect to x? That is 1. So it is only c1 plus, next it is c2 into 2x, that is 2c2x plus, next one is what is the differentiation of x cube? It is 3x squared, so it is 3c3x squared plus plus. And next, what is the differentiation of x to the power n? It is n into x to the power n minus 1. So here you can write ncnx to the power n minus 1. Is it clear now? But now in this case, in number one relation, there is no x out there. So that means you put x is equal to 1 here. Okay? So putting x is equal to 1. So putting x is equal to 1 in these equations, what do we get? So what do we get now? Putting x is equal to 1, what do we get? N into 1 plus 1 whole to the power, it is n minus 1 is equal to, this is c1 plus c2 into 1 is 2c2 plus 3c3 into 1 whole square. What is 1 whole square? That is always 1 plus plus ncn into 1 to the power n minus 1. That is, it is ncn. So now you write all the terms which are on the right hand side. You should write all the terms on the right hand side in the left hand side. Okay, and the terms which are on the left hand side, you should write them on the right hand side. Okay. So, or what do we get? C1 plus 2C2 plus 3C3 plus dot 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 plus NCN. That means we are exchanging the sides. Okay. Is equal to n into, what is that, 1 plus 1? It is 2 to the power n minus 1. But we are not getting the answer. Right. So there is different answer out there. You have to prove that. In 16 number 1, this is 16 number 1, you have to prove that in number 1, C0 plus 2 into C1 plus 3C2 plus dot 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 plus within bracket n plus 1 bracket close Cn is equal to n plus 2 into 2 to the power n minus 1. That means we are not getting the answer. So sometimes you may get the question like this also. If 1 plus x whole to the power n is equal to C0 plus C1x plus C2x square plus C3x cube plus dot dot plus Cnx to the power n, prove that this expression, that is C1 plus 2C2 plus 3C3 plus dot dot plus NCN is equal to n dot 2 to the power n minus 1. But in this case, you have to prove the different relation, that is 16 number 1. I just told you that you have to prove that C0 plus 2C1 plus 3C2 plus dot 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 plus within bracket n plus 1 bracket close Cn is equal to n plus 2 into 2 to the power n minus 1, right? So let us mark it number 1, okay? But the relation, given relation is not proved out here, so you have to write down the given again, right? So let us write down the given part again. So here given is, what is given here? So 1 plus x whole to the power n is equal to, what was that? C0 plus C1x plus C2x square plus C3x cube, right? Then plus dot 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 plus Cnx to the power n. Now in this case also you put x is equal to 1. So putting x is equal to 1. So what do we get? Putting x is equal to 1. 1 plus 1 whole to the power n is equal to, it is C0 plus C1 into 1 is C1 plus C2 into 1 is square is 1. That is C2 into 1 is C2 plus C3 into 1 cube C3 plus dot dot plus Cn into, what is 1 whole to the power n? 1 to the power any number is always 1. So which is equal to Cn. So now we have to exchange these signs, okay? C0, C1, C2, C3 plus dot plus Cn, write it on the left hand side, and this is 2 to the power n, write it on the right hand side, okay? So we are exchanging the sides out here. So C0 plus C1 plus C2 plus C3 plus dot dot plus Cn, which is equal to, on the right hand side, what is 1 plus 1? It is 2 to the power n. So let us mark it number 2. So in order to prove that relation number 16 number 1, you have to add these 1 and 2. You will get the answer. Okay. So write down adding 1 and 2. So what do we get? Adding 1 and 2. What do we get? Or now you have to add those left hand sides, add those right hand sides. Okay. So now it is only C0 is here. So it is C0 plus C1 plus C1, 2C1 plus C2 plus 2C2, 3C2 plus C3 plus 3C3, that is 4C3 plus dot 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 plus. Now add these two terms now. It is NCN plus Cn is equal to, so this is your last term. NCN plus Cn is the last term here, is equal to, on the right hand side you add those right hand sides. So n into 2 to the power n minus 1 plus 2 to the power n. It is 2 to the power n. Okay. So now you can prove the required result, that is 16 number 1. Okay. So now let us simplify it again. So how will you simplify it? Or C0 plus 2C1 plus, this is 3C2 plus 4C3 plus dot 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 plus. So what is common out here? It is Cn is common. So within bracket, what do we get? It is n plus 1 Cn, which is equal to. Now on the right hand side, you have to prove that it is to be proved that n plus 2 within bracket. So within bracket there is n plus 2 into 2 to the power n minus 1, right? So first term, keep it as it is, n into 2 to the power n minus 1 plus this 2 to the power n. You should write it in terms of 2 to the power n minus 1, right? 2 to the power n minus 1, but there is only 2 to the power n. So what should you write here? Into 2. So if you write 2 to the power n minus 1 into 2, so if you multiply them, the powers will be added. So if powers are added, then what do we get? 2 to the power n minus 1 plus 1. That is minus 1 plus 1 gets cancelled. You get this 2 to the power n. Okay. So why did I write 2 to the power n minus 1? So that you can take common. So that you can prove 16 number 1, isn't it? So you have to prove n plus 2 into 2 to the power n minus 1 on the right hand side. Okay. So this left hand side is C0 plus 2C1 plus 3C2 plus 4C3 plus dot 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 plus n plus 1 Cn is equal to, what is common here? It is 2 to the power n minus 1 common. So within bracket, what do we get? N plus 2 into 2 to the power n minus 1. So it is done. Okay, so proved. So we have proved 16 number 1. So I think you have understood it. Okay, so this is very important question. So next part, 16 number 2. In 16 number 2, what is the relation to be proved? If 1 plus x whole to the power n is equal to c0 plus c1x plus c2x square plus dot 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 plus 6n x to the power n, then you have to prove that number 2 is c1 minus 2c2 plus 3c3 minus dot 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 plus minus 1 whole to the power n minus 1 into n cn is equal to 0. So now here also you have to prove it from given. So now we will prove number 2, 16 number 2, right? So 16 number 2. Let us write down the given part. So what is given here again? It is 1 plus x whole to the power n is equal to c0 plus c1x plus c2x square plus c3x cube plus dot 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 plus cn x to the power n, right? So now what will you do here? Again differentiate both the sides with respect to x. Okay? Again differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So what do we get? This is just like your x to the power n. 1 plus x is taken as x. So what is this differentiation? N into 1 plus x whole to the power n minus 1 into, again differentiate the term which is assumed as x. That means, what is the differentiation of 1 plus x? That is always 1. So which is equal to? So 1 we don't write, actually 1, isn't it? Now differentiate the right hand sides. For c0 it is 1 because this is the only constant term there. But c1 is with x. So what is this differentiation? c1 plus x square, 2x, that is 2c2x plus this is 3c3x square plus dot 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 plus this is your ncnx to the power n minus 1. That is differentiation of x to the power n is n into x to the power n minus 1, right? So now what is to be proved here? We have to prove that the c1 minus 2c2, c1 minus c1, this would be minus 2c2 plus 3c3 minus dot 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 minus 1 whole to the power n minus 1 dot ncn is equal to 0. That means you put x is equal to minus 1 out here. Okay? So if you put x is equal to minus 1 here, you can get the result, right? So write down putting x is equal to minus 1. Putting x is equal to what? Minus 1. Okay? So let us put x is equal to minus 1 here. So let's see what happens. Or n into x is minus 1, that is 1 minus 1 whole to the power n minus 1 is equal to, it is c1 plus 2c2 into what is x here? Minus 1 plus 3c3, this is your minus 1 whole square. Then write down plus dot 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 plus. So x to the power n minus 1. You first put the value for x. What is the value for x here? It is minus 1 whole to the power n minus 1 into ncn. Is that clear? So let's simplify it. Now this 1 gets cancelled. That is 0 to the power n minus 1 is always 0. 0 into n is always 0 is equal to c1 plus or minus minus 2c2. What is minus 1 whole square plus that is 3c3. Then comes again minus. It will be alternate positive negative sign. Plus minus etc. Okay. Dot 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 plus minus 1 whole to the power n minus 1 into ncn. Right. And so next, what will you do? We will write down this 0 on the right hand side and all of the terms of the right hand side in the left hand side. So you can take c1 minus t2, you can write c1 minus 2c2 plus 3c3 minus dot 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 plus minus 1 over the power n minus 1 dot ncn. You write it on the left hand side and 0 on the right hand side. That means we are exchanging their sides, so you don't have to change the sign. That is c1 minus 2c2 plus 3c3 minus dot 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 plus minus 1 whole to the power n minus 1 into ncn, which is equal to 0. Right? So problem number 2 is proved. That is 16 number 2 is done. That is proved. Okay? So we'll do the next question now. So now we'll do the next question, that is 17 number 2. So you know that this is the determinant form. You know how to expand it, isn't it? So it is given that if y is equal to, this is in the determinant form, 3 rows and 3 columns, right? What is the first row here? F of x, g of x, h of x, second row lmn, and what is the third row? It is abc. You have to prove that dy by dx, that means you have to differentiate both the sides with respect to x and prove that dy by dx is equal to, in the first row there is f dash of x, z dash of x, h dash of x, and element and abc are constant. They should remain same, right? So let us write down the given part here. What is given here? So y is equal to, this is your f of x, z of x, this is your h of x, so this is element, and this is your ABC. Alright? So let us expand it. Let us expand it now. Then you can differentiate it, isn't it? So let us expand it with respect to the first row. That means, therefore, y is equal to, this is plus, minus, plus, you know that. Alternate positive negative signs should be written. So plus f of x. So if f of x is considered, you have to delete the row and the column through the element. Forget about this row, for first row, f of x, g of x, h of x, and f of x, l and a. So what remains? M, n, b, c. This is the second order matrix. So by cross multiplication, you have to simplify or expand it. M into c, mc, minus b into n, bn. Alright? So this is the first term. Then comes minus g of x. Now we are considering this second term, which is in the first row. If this g of x is considered, you have to delete the row and the column through that element. That is, first row and second column are deleted. What remains? L, N, A, C. This is the second order determinant. Now we can expand it. L into C, L, C, minus A into N. That is minus A. Then what is the last one? Plus h of x. That is the function of x, right? Each h of x is considered, you have to delete the row and the column through that element h of x. That is, this first row and this third column are deleted. Okay? So what remains here? L, M, A, B. This is the second order determinant, right? And you have to expand it. Now cross multiply L by B. That is LB. LB, then comes minus sign always. You know that in expansion of the second order determinant, and AM, that is AM, right? So this is the expansion. Now you can differentiate it, okay? So you are differentiating both the sides with respect to x. Only f of x, g of x, h of x are the variables, but within bracket, mc minus bn, lc minus an, and lb minus n, these are all constant, right? So write down differentiating both the sides with respect to x. So differentiating both the sides with respect to x, right? So therefore dy by dx is equal to, what is it? MC minus Bn remains same. That means you have to differentiate only f of x, because MC minus Bn is a constant, right? So it is f dash of x and within bracket MC minus Bn, right? Then comes minus. This LC minus A is constant, remains same. You have to differentiate only g of x, that is z dash of x and within bracket LC minus An, right? Then plus, what is the differentiation of h of x? H dash of x and within bracket this LB minus Am remains same. That is LB minus Am. Is it clear now? Now again, this is an expansion of a determinant, isn't it? So this right hand side is the expansion of a determinant. What is that determinant now? So you can write down this expansion in terms of a thought or a determinant again, isn't it? So therefore dy by dx is equal to, so what will be in the first row? This f dash of x, then z dash of x, then comes h dash of x. Okay, so how can we get this MC minus Bn, LC minus An and LB minus An? That is, second row will be LMN and the third row you should write it as ABC, so that if you differentiate, if you expand this determinant, again you will get this same expression. That means this expansion is the this expression, that means this expression is the expansion of this determinant. Okay, so this determinant, that is differentiation, is, and this differentiation is proved. So in this way you can do the answer. Okay, so this proved. So now we'll do the next question. You can copy it. So now we'll do the next question, that is question number 18. If x is equal to t minus e to the power minus t square divided by 2t square, it is given. You have to prove that t into dx by dt plus 2x is equal to 1 upon 2t plus e to the power minus t square. You have to prove the value for dx by dt, right? Since you have to get dx by dt, so both x and t are the variables in this given part. In the given part, both x and t are the variables, right? So before you differentiate both the sides with respect to t, you can cross multiply. So or it is 2t square x is equal to t minus e to the power minus t square. Okay, so now we can differentiate both the sides with respect to t. So differentiating both the sides with respect to t. So therefore 2 is constant out here, so it is written outside third bracket. Now for t square x you can use UV rule. Now first you differentiate t square with respect to t. What is it? 2t, x is kept as it is, plus then again t square remains same into, what is the differentiation of x with respect to t? It is dx by dt. Third bracket is closed, which is equal to, now what is the differentiation of t with respect to t? That is 1, minus sign is there. Now how can you differentiate e to the power minus t square? It is just like your e to the power t. What is the differentiation of e to the power t? It is e to the power t, but here you should write e to the power minus t square. But you should differentiate the term which is assumed as t. So which function was assumed as t? Minus t square. So you have to differentiate minus t square with respect to t. So into, what do we get? Minus 2t. That is, differentiation of minus t square is minus 2t. So I think you have understood it. Okay. So now, now let us multiply them. 2 2s are 4tx. It is 4tx, right? Then plus 2t square. 2t square into dx by dt it is 2t square into dx by dt is equal to 1 plus, that is minus into minus plus. You first write 2t, then e to the power minus t square. So that is your 2t, right? So this is your 2t. So I think you have understood it, okay? So now we can take common here. So what is common on the right hand side? You can take 2t as common, right? So 2t as common, within bracket, what do we get? This is 2x plus t into dx by dt, which is equal to, on the right hand side, what do we get? 1 plus 2t e to the power minus t square. Okay? Now you should prove t dx by dt plus 2x is equal to 1 by 2t plus e to the power minus t square. So on the left hand side, there is only t dx by dt plus 2x only. So you can take this 2t to the right hand side. Okay? So, or this is your 2x plus t into dx by dt is equal to, on the right hand side, what do we get? 1 plus 2t e to the power minus t square, this whole divided by what? Whole divided by, this is 2t. Clear? So now, so you can separate the term on the right hand side. You can separate the term on the right hand side, okay? So left hand side remains same, 2x plus t into dx by dt. Now separate the term on the right hand side. You can split the term there, that is 1 upon 2t, 1 upon 2t plus what? 2t e to the power minus t square divided by 2t. So here 2t gets cancels. Now first you write t dx by dt. It is t dx by dt, then plus 2x is equal to, this is 1 by 2t, then plus, what is the second term out there? It is e to the power minus t square. So it is e to the power minus t square. So it is proved. So I think I've understood it. So copy it. Now we'll do the next question. Now, we'll do the next question, that is question number 19. If y root over x square plus 1 is equal to log, within bracket, within square root x square plus 1, this is the first term, minus x within bracket, prove that x square plus 1, again within bracket, dy by dx plus xy plus 1 is equal to 0. So you can prove it from given part, okay? So given here is y root over x square plus 1 is equal to log of, within bracket, root over x square plus 1 then minus x. Okay, so let us differentiate both the sides with respect to x. Okay, so differentiating both the sides with respect to x. So, or you can use UV rule here, isn't it? Both x and y are the variables. So what is the differentiation of y with respect to x? Dy by dx, then x square plus 1 remains same, plus again y into, what is the differentiation of root over x? That is 1 by 2 root over x, that is x square plus 1 into, again differentiate the term which is assumed as x. So in this case, x square plus 1 is assumed as x. Now differentiate x square plus 1. What is it? It is 2x. Right? So which is equal to, on the right hand side, this is the form log x form, isn't it? What is the differentiation of log x? 1 by x, that is 1 upon root over x square plus 1 minus x into 1 by x into, again differentiate the term which is assumed as x, that is root over x square plus 1 minus x. You should differentiate it, right? So what is the differentiation of root over x square plus 1? It is 1 by 2 root over x square plus 1 into what? 2x. Because it is in the form root over x, so x square plus 1 is assumed as x. So what is the differentiation of root over x? It is 1 by 2 root over x. And here x square plus 1 is x actually, isn't it? So again differentiate the term which is assumed as x. So here x square plus 1 was assumed as x. So what is this differentiation? It is 2x. Then what do we write? Minus, what is the differentiation of x? That is 1. Is that clear? So we can cancel it. This 2 gets cancels. Okay. So here also 2 gets cancels. Or this is your dy by dx within square root. It is x square plus 1, right? Plus it is xy divided by root over. This is x square plus 1, which is equal to, this is 1 upon within square root x square plus 1 minus x. Alright. So here what's the LCM? You can take the LCM out here. So what's the LCM? It is root over x square plus 1 is the LCM. Now this LCM is divided by denominator. That is 1 time. So 1 into x is x minus. Now multiply this LCM by 1. That is root over x square plus 1. Is that clear now? But in this case, actually these are two same quantities, but you said take minus common here, so that we can have root over x square plus 1 minus x, right? So or dy by dx root over x square plus 1 plus xy divided by root over x square plus 1 is equal to, here it is 1 upon root over x square plus 1 minus x into. Now in the denominator you take minus common. So what do we get within bracket? Root over x square plus 1 minus x. Bracket close, whole divided by root over x square plus 1. Okay, so that we can cancel these similar terms, isn't it? That is root over x square plus 1 minus x will be cancelled, right? So let us simplify it again. So now what will you do? Or dy by dx root over x square plus 1. Let us write down the remaining terms. Plus xy divided by root over x square plus 1 is equal to. So what is there on the right hand side? It is this is minus sign is there because minus was taken common outside, isn't it? So minus 1 upon, this is root over x square plus 1. Okay. So now we can do cross multiplication here. Now cross multiply by root over x square plus 1. So here comes root over x square plus 1 within bracket dy by dx root over x square plus 1. Okay. Then plus xy divided by root over x square plus 1, which is equal to, so what is there on the right hand side? It is only minus 1. So is that clear to all of you? So now you can multiply them, or root over x square plus 1 into root over x square plus 1. What is it? Square root of a into square root of a is a. Here also root over will be removed. Square root will be removed. What do we get? X square plus 1 into dy by dx. Right? Then plus. Again multiply this fraction by root over x square plus 1. Root over x square plus 1, root over x square plus 1 gets cancels. Plus xy, which is equal to minus 1. Okay? So now in the next step, what will you do? So minus 1, take it to the left hand side. So or it is x square plus 1 into dy by dx. Okay? Then plus xy, then minus 1 is taken to the left hand side. What does it become? Plus 1, which is equal to 0. So it is proved. So we got the result. Okay? So now we'll do the next problem. So now we'll do the next question, that is if y is equal to this expression. Okay, you have to prove the value for dy by dx is equal to y by x within third bracket a1 upon a1 minus x plus a2 upon a2 minus x plus a3 upon a3 minus x, right? So let us write down the given part first. So what is given here? Y is equal to a plus a1 upon x minus a1 plus a2x divided by x minus a1 x minus a2 plus it is a3x square divided by x minus a1 x minus a2 x minus a3. Okay. So now we have to simplify it first. So in this case, don't simplify all the terms together, right? It will be difficult for you to simplify it, right? So let us simplify the first and the second term only. Let us take the LCM for the first and the second term. So below 1 there is 1, right? So or y is equal to, what's the LCM? You know the LCM, 1 and x minus a1 was the LCM. It is x minus a1 is the LCM. So in the numerator, x minus a1 plus a1, right? Then plus a2x divided by x minus a1 x minus a2. Keep it as it is. Second term and third term remain same. That is plus a3x square divided by x minus a1 x minus a2 and x minus a3. Is that clear? So here you can cancel this minus 1 plus 1 gets cancelled. So what do we get? Y is equal to x upon x minus a1 plus second term a2x, it remains same, x minus a1 x minus a2 plus then it is a3x square divided by x minus a1 x minus a2 and this is x minus a3. Is that clear to all of you? Now again you have to simplify the first two terms again. Take the LCM and simplify it, right? So let us take the LCM and simplify it, right? So or y is equal to first two terms. What's the LCM? It is x minus a1 into x minus a2 is the LCM for these two terms, right? Now this LCM is divided by x minus a1, so it remains x minus a2. Now it should be multiplied by x, right? So x into what? X into x minus a2, okay? Then plus what? Now this LCM is divided by these two factors. That means it is 1. All the factors will be cancelled. That means 1. So 1 into a2x, that is a2x. Okay? Then third term remains same. That is a3x squared divided by. So what do we get? X minus a1, x minus a2, then write x minus a3. Is that clear now? So let's simplify the numerator. Y is equal to, this is x square minus a2x plus a2x divided by x minus a1 x minus a2. Then plus third term remains same, that is a3x square divided by we have here x minus a1 x minus a2 into x minus a3. Is that clear now? So next, what will you do? So here a2x gets cancels. Again take the LCM from these two remaining terms. Or, so that is y is equal to, what's the LCM now? What is the LCM? It is x minus a1, x minus a2, then x minus a3. Okay? So what is there in the numerator now? Now this LCM is divided by x minus a1, x minus a2. So this x minus a1, x minus a2 factors will be cancelled. So what does it remain? X minus a3. That is x square should be multiplied by x minus a3. Then plus. Again this LCM should be divided by these three factors. They are same factors. If you divide it, all the factors will be cancelled. You will get only 1. So 1 into a3x squared, that is a3x squared, right? So now let us simplify it again. On y is equal to, this is your x squared into x, this is your x cube minus x squared a3 plus a3x squared, this whole divided by, what do we get? x minus a1, x minus a2, this is your x minus a3. Is that clear? So here you can cancel this, x square a3 will be cancelled. These are of different sign, minus plus, okay? So now let us write down the remaining terms now. So what is the simplified expression here? That is y is equal to x cubed divided by, it is x minus a1, x minus a2, x minus a3. So is that clear to all of you? Okay, now you have to find out the value for dy by dx. In the question, the value for dy by dx is given out there. Okay. So now, what will you do here? Will you differentiate it directly? No. You have to take log on both the sides, right? So if you take log on both the sides, it will be easier for you to differentiate it, and you can get the required result as given in the question. So taking log on both the sides. Taking log on both the sides, okay? So this is your log y is equal to log of, now within second bracket you write these fractions x cube upon x minus a1, x minus a2, x minus a3. Second bracket is closed, right? So next, what will you do? So this is your log of a by b. You know log of a by b, isn't it? What is log of a by b? What is the properties of logarithm for log of a by b? It is log a minus log b. So we have here, so log y is equal to log a. What is log a? It is log x cube. Then minus log b. Minus log, which is b here? X minus a1, x minus a2, and this is x minus a3. Then second bracket is closed. Now here also you can use log of ABC. You know logarithm of the product of three numbers is equal to sum of their logarithms, isn't it? So or log y is equal to, this is 3 log x. Because of this log, 3 becomes the coefficient of log x, okay? So here log of ABC, you know that log a plus log b plus log c. But because of this minus sign, the sign changes, right? So minus log of x minus a1, right? Minus log of x minus a2, minus log of x minus a3, minus log of x minus a3. So I think you have understood it, okay? Now you can write down, now you can differentiate both the sides with respect to x, okay? So differentiating both the sides, with respect to x, okay? Now we'll differentiate both the sides with respect to x, okay? So what is the differentiation of log y with respect to x? It is 1 by y into dy by dx is equal to 3 is constant. What is the differentiation of log x? 1 upon x, right? Minus, again, what is the differentiation of log of x minus a1? It is just like your log x. What is the differentiation of log x? 1 by x, but here it is 1 upon, instead of x there is x minus a1. Again differentiate the term which is assumed as x, that is x minus a1 was assumed as x, and if you differentiate x minus a1 with respect to x, you will get 1 minus 0. That is differentiation of x is 1, minus for a1 it is 0, that means 1 minus 0 is always 1, right? Then minus 1 upon x minus a2, right? Similarly, what is the last one? Minus 1 upon x minus a3. So this is the differentiation, but you have to prove a different term, isn't it? So you have to prove that dy by dx is your y by x within third bracket. It is a1 by a1 minus x plus a2 by a2 minus x plus a3 by a3 minus x, right? So now you have to simplify it further. Now what we will do here is, let us keep the left hand side as it is. Dy by dx is equal to, now this is your 3 by x. This 3 by x can be written as 1 upon x plus 1 upon x plus 1 upon x, isn't it? This 3 by x can be written as 1 by x plus 1 by x plus 1 by x. Then you write minus 1 upon x minus a1 minus 1 upon x minus a2, then write minus 1 upon x minus a3. Okay? Now again you can simplify it further. So how do you simplify it? Let us take the term with pair on the right hand side. You take 1 upon x minus 1 upon x minus a1. Then you take 1 upon x with 1 minus 1 upon x minus a2, then you can take this term 1 upon x with 1 upon x minus a3. Okay, then simplify it. Or 1 upon y into dy by dx is equal to, write down within bracket 1 upon x minus 1 upon x minus a1, right? This is the first term now. Now next, plus 1 upon x plus 1 upon x with minus 1 upon x minus a2, right? Then write on this cross marked term, that is plus 1 upon x minus 1 upon x minus a3. Okay? Now we have taken the terms in pair. Now we have to simplify that terms which are taken in pair. Okay? So let us take the LCM. 1 upon y into dy by dx is equal, what's the LCM here now? It is x into x minus a1. Now this LCM is divided by x gets cancelled, so it is x minus a1, then minus this LCM is divided by x minus a1 will be cancelled, so it remains x only, so x into 1 is x. Okay? Then plus, again what's the LCM here? X into x minus a2. Now in the numerator, what do we get? X minus a2 minus x plus, what is that last term? What's the LCM? It is x into x minus a3. So it is x minus a3 then minus x. Is that clear? Now here you can cancel. You can cancel this xx. Here also plus x minus x. Here also plus x minus x will be cancelled. Right? So now, can you prove the required result now? Can you prove it, required result? So what are the remaining terms now? 1 upon y into dy by dx is equal to, this one is minus a1 divided by x into x minus a1, right? Then plus minus a2 divided by x into x minus a2, right? Then the last one is, here also x gets cancels, plus minus a3 divided by x into x minus a3. So you can cancel the minus sign which is written in the numerator by taking minus sign common in the denominator in each term, isn't it? In each term in the denominator you can take minus as common, right? So let us take minus as common from the denominator. Okay? So it is 1 by y into dy by dx is equal to minus a1 divided by, this is minus x, so it is a1 minus x. So we are taking minus common from the denominator because we can cancel this minus sign which are both in the numerator as well as denominator, right? Plus minus a2 divided by minus x within bracket a2 minus x. Okay? Similarly, plus minus a3 divided by minus x common within bracket a3 minus x, right? So here minus minus gets cancels, minus minus gets cancels, here also minus minus gets cancels. So now what will you do in the next step? You can take common here. We see that 1 upon x is common out here on the right hand side. So you can take 1 upon x as common from the term from right hand side. That is dy by dx. So now you can take common 1 by x from the right hand side. So it is 1 upon x within bracket, what do we get? a1 upon a1 minus x plus a2 upon a2 minus x, right? What is the third term? Plus it is a3 divided by a3 minus x. Is that clear now? Now you should get the value for dy by dx. Now cross multiply by y here, so it is y by x, isn't it? So or dy by dx is equal to y by x, and within bracket what do we get? a1 upon a1 minus x plus a2 upon a2 minus x plus a3 upon, this is your a3 minus x. So I think it is proved, I think, isn't it? So you have to prove that dy by dx is equal to y by x within bracket a1 upon a1 minus x plus a2 upon a2 minus x plus a3 upon a3 minus x. So that is proved. Is that understood? So this question is very, very important. You can practice it at home, okay? So this question is very, very important. Again, you practice it at home, so it will be easier for you to simplify it, okay? So this much is for today. So we did 5 problems today. You revise all the problems that we did today also, okay? So in the next class, we'll do question from the HS question papers, right? So this much is for today.